work measurement is nothing but basically you're capturing a time for doing a certain thing. And again, when we do work measurement, either stopwatch or different techniques like MODAPTS or MTM or anything like that, we tend to identify an average skilled worker doing this work at a normal pace. The reason we try to do this for average skilled workers because that's the average for the population, you can say, because we don't want a person who can do this at a very fast pace or a person who can do it at a very slow pace. We tend to capture average overall, what average person has to do this, because he has to sustain 8 to 10 hours of work. That's the reason we try to capture a person who's doing this job at an average average operator with an average pace. Again, significance of work measurement. Of course, there are a lot of benefits using the work measurement, and I think some of them are basically used in like the employee training, the standardized work, and the data for the line balancing. I kind of the principles for the Toyota production system. Now, apart from these three, that apart from all the things listed here, there are a couple of things, other things also which can be used to capture some data and required for like for process improvement and all that kind of stuff. All right, again, this slide basically talks about what are the different or it's a generation, how we came up, how we advanced in terms of work measurement. If you look at the first generation, it was basically an estimation or a swag. Now someone used to say, yeah, this takes, based on my experience, this takes 20 minutes, 30 minutes, and of course they were looking at some historical data also. Again, those were not accurate. Again, it was based on someone's experience. Again, you're not looking at it. His estimation might be based on somebody working at a very fast pace or slow pace, or even might be at average work, but we don't know that. The second generation, what we call, is stopwatch studies and also the work sampling techniques. Stopwatch is still popular among a lot of for a lot of manufacturers or for a lot of companies. It kind of still, it's kind of a gold standard, you can say, for some people. Stopwatch is something accepted throughout the world. But the third generation of time studies, that's basically your MODAPTS, that's your predetermined time studies, are getting popular, and also they are very popular among the world, especially MODAPTS. The reason it's getting popular, especially in the union environment, is you're not using stopwatch, and you're not looking at your operator to do something. Usually, when you're doing the time study, some people get kind of it's like somebody's looking over his shoulder kind of thing. But MODAPTS is not like that. MODAPTS in MODAPTS, or you can say the predetermined time study, you're looking at the activity of it, your hand movement, your leg movement, or your finger movement, and then you're capturing and assigning some times to it and coming up with a standard time for that. So that's the reason it's gaining popularity, and also I mean, especially in the union environment, that's the only method they recommend. Again, as I said, stopwatch study, again, typical work measurement applications. A stopwatch study, again, is used for continuous or direct or indirect labor studies. Again, it's still kind of a gold standard even for now. Even some people, some companies, even that when they do MODAPTS, they still want to do a stopwatch study just to verify whether they have the right numbers. Again, work sampling study. Again, this is generally applied to study where it's a non-repetitive task and for a long cycle time, especially when you need to know what's the utilization of a machine for the whole shift, or a utilization of some personnel, your support personnel for a shift, or how long does it take for for an operator to do certain things. That's when the work sampling study will come into picture. I think I'll go into detail now. What are the benefits between benefits of stopwatch, work sampling, and also the MODAPTS. Again, MODAPTS is it's similar to your stopwatch. Is applied to repetitive tasks with shorter cycle times. Again, these are divided into mods, and each mod based on what you're doing. You're moving your hand, moving your finger, moving your shoulders, or twisting your uh, uh, waist. You assign certain times to it. That's the MODAPTS. So next, again, the stopwatch study. Again, as I said, stopwatch study is most even now it's very popular throughout the world. And some of the things to keep in mind when you're doing the stopwatch study is before an observer can start the stopwatch study, he has to clearly know when is the start of a task and end of a task. It'll be good if there's if an operator is using a start button and the stop button, or if there's some light indicators. If something he does something, it brings out the light or something like that. But the primary thing is he has to identify before he starts his study to know exactly when to stop, when to start, and when to stop. And also, it has to be short. Now, it can be long. I think when we say short, you might ask, how short? Again, we're dealing with now like between 30 seconds or 5 minutes. I mean, 5 minutes is a stretch, but hopefully it's between 10 seconds to a minute. Again, performance rating. I think the performance rating is once we get the standards, or once we do this study, once we get the time from this time study, we basically rate the performance, or rate the performance of the operator we observe. The reason is because we want to see, okay, is this an average guy doing it at an average pace, or is one of those guys who's doing it at a very fast pace? So based on that, we put a multiplier, either based on how fast he's doing or how slow he's doing. We use a multiplier to get that normal or the standard times. Again, work sampling. Work sampling is a technique used to categorize times into different categories. Now, if you look, what we call is, especially for machines, what we call is time in study. Now, you want to look at the time in different categories, like busy time, your waiting time, your working time, your block time, and your downtime, and all that. That's when your work sampling technique will come into picture. Again, need for work sampling. You do work sampling, again, as I said. You want to see a utilization of a man, or utilization of an operator, or a utilization of a machine, and also to calculate the total time devoted to the various activities. I think we have some examples in the end. I can walk you through that, and so you can get a clear picture of where we do work sampling, where we do time study. Time study, again, stopwatch, or your other predetermined time studies. These are the steps kind of involved in doing the work sampling studies. The first thing, like in any project, you establish the goal or the object of the study. This might be, hey, someone might come and say, I want you to do a work sampling on this guy to look at how utilized this person is, or how idle this person is. So that becomes the goal of the study. And second step is to basically identify the subject. The subject might be an operator, might be a machine, or might be any object. It might be a truck, or AGV system, or any kind of an object. The other thing is the step 3 is basically identify the list of activities it has to do. Let's say, example, an operator is working on a machine. We need to list out all the different activities or categories of activities. Now, whether he is doing a setup time, is loading a part, unloading a part, cleaning up a part, quality checking, again busy time, might be your idle time. So these are different categories of work we need to identify, so that once we do the work sampling, now we can put these samples in these various buckets. Step 4 is now determine the number of observations you need to do over a period of time. Stepwise, again, you make random observation, record them, and basically put them in different buckets of different categories. Then step 6 and step 7 is basically you're looking at all the data you collected, you're summarizing, and then coming up with a conclusion, or if you're doing some recommendation, that's where you do in step 7. Again, this is a good example of a list of activities. This might be the codes. And if you were asked to do a work sampling on a nurse in a hospital, and this might be some of the things nurses will be doing typically in the day of the work, right? So it might be waiting, search, like you can assign the task code for each and every categories, and based on your observation, you can put those your observations into all these categories. Again, still in work sampling. In work sampling, there's something called elemental ratio analysis. It's basically your percentage of time in each category. Like an example below, we made some observations. Now we made a total of 387 observations, but we categorize some of the observation to different categories. And if you don't just look at the percentage, if you look at the observation, it won't give you a real good picture of what percentage of time he or she is doing that kind of thing. So when you put that into percentage, it's more easy to understand. So that's the reason we do basically we categorize the observation into a percentage, and that gives a better picture of the states for different operator. So like in this now, we had idle work, setup, quality control, clean, material handling, and if you had to just look at the observation, it's very hard to understand or get a clear picture of even though he's spending much time on work, but exactly we don't know what percentage of time he's spending on the doing on work. But when we convert this into a percentage, it gives a better picture of all the tasks for the operator there. Again, coming to the predetermined time study, as I said earlier, these are the third generation of work standards. And one good thing about the predetermined time studies is the operators are not stressed or don't feel that somebody is looking over the shoulder, and basically we are measuring some of the tasks which are associated with the body movements, and each body movement will be assigned a time. So if I'm moving my hand from left to right, there's a time associated with it, and or if you're just using your fingers, if you're walking, if you're bending, if you're stretching, trying to reach an object above your shoulders, those are what we call mods, and each of these mods have time associated with it. So, and also one thing which stopwatch doesn't do good is what are the non-value added activities, or you can say what are the ergonomic issues, especially when you do the MODAPTS time studies. It can point out some of the ergonomic issues which comes up with the study too. Um, Again, I think it's the same thing. The predetermined time studies. Um, these are accepted throughout the world, and either you go to China or you go to US or something, it's the same standards or the same codes, and it's pretty reliable and consistent. We have done several studies doing both stopwatch and MODAPTS, and and it's consistent. It matches pretty well with your time studies with the stopwatch. And no, I don't say just the MODAPTS is one of the third generation time studies, but there are other similar techniques like MOST and MTM. Most stand for Maynard operations sequence technique, and MTM basically is methods time measurement. I think it's they try to capture the same essence of MODAPTS. Some companies like something over something, a few other things, but it's the same technique. You're trying to observe the methods or observe the operators in terms of the body movement. So some companies like MTM, some companies like MODAPTS, but I think MODAPTS is much more popular compared to the other two techniques. I think this is a good comparison between stopwatch and MODAPTS, or you can say predetermined time study. The first thing is for stopwatch, of course, you need a stopwatch for this, and this can be very intimidating. As I said, you don't want operators don't like somebody watching over the shoulders. For some reason, they might do it in a very fast pace. They might think the work they were doing, they were slow, and they might pick up pace when someone is watching them, or they might do slower than what they were doing. So it's very intimidating. Whereas MODAPTS, you don't use a stopwatch, and it's very less intimidating compared to a stopwatch study. The other thing is the performance rating. When you do a stopwatch study, you need to do a performance rating. You need to say at the end of the study, you need to say whether this operator was doing at a normal pace, the faster pace, or a slower pace. Whereas in MODAPTS, you don't rate this operator because you're not measuring how fast or how slow the operator is doing, but you're looking at your the body movements. Again, stopwatch is not ergonomically sensitive, whereas MODAPTS is. It basically records body movements, and if you have to go through the MODAPTS study and someone says, yep, somebody is bending and somebody is picking apart over his shoulder, then we can circle this out and say, well, this is something. I mean, if it's once in a while, that's fine, but if it has to repeatedly keep bending, keep stretching over the shoulders, or keep picking apart over the shoulder, then it becomes an ergo issue. And I think MODAPTS does a good job of pointing that out. And stopwatch is not sensitive to the methods, not method sensitive. Again, it basically just records what you're doing, but it's not. It doesn't do a good job of how it's done or something like that. Whereas MODAPTS does a good job in method sensitive because it's more sensitive because you're measuring the body movements rather than just putting a time in case of the stopwatch. Again, this is a comparison between the work sampling and time study, and both of them have pluses and minuses, and it depends upon the application, and work sampling doesn't require continuous observation. So that means an observer need not have to be standing in front of a person or a machine continuously for 8 hours or something like that. Whereas time study requires either stopwatch or MODAPTS or predetermined time study. It will require continuous observation. Because in work sampling you're not required to be there continuously. the total work hours expended total work hours spent by observer is less compared to the person who's doing a time study. Again, in work sampling, the operator is not subjected to a stopwatch, less intimidating, whereas in time study, an operator is subjected to a stopwatch. In work sampling technique, a single analyst or observer can study several operations simultaneously. He can observe operator 1, then go back to operator 2, 3, or 4. But a rule of thumb based on the experience is I think not to do more than 5 operators or machines at a given time. Whereas time studies, you're just focusing on one person or one activity who has to continuously be there. Next is basically you're looking at application of work measurement. Again, in PMC, we use again based on the work. We might use stopwatch. We might use MODAPTS, or we might use work sampling technique. Again, it depends upon what the customer wants, and sometimes the customer requires us to do both stopwatch and MODAPTS, because some customers are still not sure how MODAPTS work. They want to get they want to validate the numbers coming out from MODAPTS study. So that's the reason some customers require both a stopwatch and time study. And some operators, some companies still use stopwatch studies. There's nothing wrong there, but especially in the non-union environment, people are okay to go there, measure it up using stopwatch. Again, based on application of we use a lot of time studies for lean manufacturing, again for simulation, for planning and scheduling. Again, you're measuring a process or measuring an operator, the time it takes to do a certain task. This is a typical, as you see, I think in a case study here, we had to do a line rebalance to look at, they wanted to reduce the manpower, and they wanted to come, first they wanted to do, to see what are the actual cycle times for this engine assembly line. And you can see from here, they wanted us to do both MODAPTS and the stopwatch study. Again, the customer was not sure whether the MODAPTS was doing a good job, or he was kind of hesitant to understand the concept of MODAPTS. So that's the reason he asked us to do both the stopwatch and the MODAPTS study. And if you can look at the table on your left-hand screen, you have the stopwatch time. And if you look at station 140, stopwatch said it's 15.576 seconds. Your MODAPTS came up with 14.48 seconds. Now, pretty close they are. Again, it depends upon. Again, one of the things. One of the issues with stopwatch study, again, it depends upon the observer, how he does a performance rating of the person he observed, and that is very subjective. I can say this guy is working at a normal pace, whereas some other person might say, well, this guy might be working at 120% at a little higher rate. So that is where the time study becomes little, I don't say inaccurate, but that's where it might throw off your cycle times there. Whereas MODAPTS it doesn't matter. It doesn't consider the performance rating. It just consider the body movements, as I mentioned to you, and I feel that is a little more accurate because you're not doing a performance rating on the operator. And of course, after the study, we did this study and we did a line rebalance, and we were able to reduce, I think, 5 people on their assembly line, and that was kind of coming out to be 1.5 million savings in a year. Um, Again, this is a case study where we used a work sampling technique, and here we were asked by customer to come and observe. Again, this was for a cigarette manufacturing company. They wanted to come and see. They were getting a lot of complaints from their operators saying that they were overutilized, and the management didn't know how to assess their utilization. So that's the reason we were asked to come there and take a look at their utilization of the different categories of people there. And as you can see, there were three different categories of people there. One person was a maker, packer, and support. Again, they gave us your target was around 95% utilization, and we did a work sampling study again to find the overall utilization and also where exactly they were spending most of the time. And of course, like some operators were utilized, especially the support operator utilization was close to 82%, but some were not that utilized. Somewhere like the packer operator was only 66% utilized, whereas the maker operator was only 73% utilized. And management was able to go back and show the studies, show the operators these studies, and they were able to do some reduce some of the tasks, especially for the support operator, was kind of utilized 82%, and sometimes they were again it depends upon the shift, as you can say, it depends upon the time of the day. They're pretty highly utilized. Again, this is one more case study, looking into to reducing the indirect labor cost. When I say indirect labor cost, again it means again your support personnel in the plant, not delivering the material to the line, the maintenance crew and all this kind of stuff. And we used a stopwatch again for this. The customer was more comfortable for us to use stopwatch instead of MODAPTS or any other techniques. And this study kind of helped them. I mean, in fact, we were able to reduce a manpower year based on the studies we did, and there was $5 million annual savings for the client.